We're going to do another normal probability question, but this one's a little different. In this problem, we are going to work the problem in sort of an inverse fashion, in a reverse fashion. So let's read it and see what the clues are. If a normal distribution has a mean of 28 and a standard deviation of 2.5, what is the value of the random variable x that has an area to its right equal to 0.6700? So in this problem, we're told it's a normal distribution. We have the mean and the standard deviation given to us. But instead of them giving us a particular value of the random variable and asking for the area or probability, it gave us the area it'd like to trap, or the probability it'd like to trap to one side or the other. In this case, it's to the right side. So I went ahead and drew my random variable x here, not knowing what the value is, thus the question mark, but knowing that I need to trap 0.6700 to its right. The reason I drew it to the left of 28 is because I needed to trap far more than half of the area to the right. So I knew this random variable had to fall somewhere to the left of our mean. And just for a little extra flair there, that's our aim, is to find how far to the left do we need to go to have exactly 67% to the right, approximately 2/3 of the curve colored in. So let's go to Rguroo to get the actual value. We have all the pieces of the problem we need here labeled. So back in Rguroo, we're going to go to the probability panel. Choose probability calculator, continuous. And now we're going to actually choose this opposite choice here, this opposite bubble. I'm going to click it. And we're going to hand Rguroo a probability in hopes that it's going to return to us a random variable back. The default setting is normal. We need to put the mean in, which was 28. The standard deviation is 2.5. And here, instead of getting above, below, between, because we've chosen this opposite option up at the top, we get lower tail, upper tail, outside of the tails, and between the tails. So we want an upper tail. In other words, we want a shade to the right. And we want that to be exactly 0.67. The 00 is optional. I'm just going to put it in for the sake of it looking the same as the problem asked. And as always, I choose a graph. So we're giving it a probability, and what it's going to return to us is a value of the random variable that would do that. So we can see our answer here, and you can see they still wrote it in the way that we're used to seeing it. The probability of our random variable, some sort of inequality, the random variable's number, and then the probability. But we're seeking out our answer is the 26.9, right? The 0.67 is what we set in our request. So let's scroll down and see if this looks like our image. And in fact, it does. Take the zoom away so we can see more of it. There we are. And you can see that there's the curve. To the left of the center is 26.9, so almost 27, shaded to the yellow. Ours was shaded blue, but 26.9, almost the random variable being 27, would force 0.6700 to the right in the upper tail. So this is a way we can solve inverse probability questions with a normal model, and just know that your answer is going to be within the parentheses here in this format, or you can actually see it down here along the axis. So our question mark in the last slide is now we know it's equal to 26.9.